Alternating series test. Oh boy, we need to show three things. The first thing we need to show is that it's alternating. Look at it. Look at it. I separated my alternating part from my sequence so I can identify my AN. Then it's alternating 1. The first other thing we need to show is that it's decreasing. We need to show it decreasing, so we have a couple different ways to show decreasing. We can do it algebraically, look at the ANth plus 1 term and try to get AN, or we could take the derivative. So, well, let's just do that for funsies. I'm going to let y be a function of x. Then my derivative of y with respect to x, that's the quotient rule, low, d high minus high, d low all over low, low. Then we go, and we reduce, by that x, and then let's factor out an x. So then we write that 2 in front of there, we reduce those x's, and after the dust settles, we're left with 1 minus the natural log of x divided by x to the third. And then I heard that we need to get our critical value, so we set the numerator equal to 0. 1 minus 2 natural log x is equal to 0. Add that 2 natural log to both sides divided by 2. Then what? We got to e it up. So we e it up. We exponentiate both sides. E to the natural log of x, well, that's x is root e. Because e to the half is root e. Now what? Our other critical values when our denominator is equal to 0, and that happens when x is equal to 0. We put them on a number line. Then we check the sign of the function on those intervals. We check to the left of 0. Why would you do that? Why you do that? It's undefined there because the natural log does not exist in that dojo. No, sensei. So I pick 1, because 1's in between 0 and root e. And when I put that into our expression, we see that we have 1 over 1, all right, which is positive right there. Now we need to pick a number to the right of root e. Why don't we just pick e? Clearly, root e is smaller than e, so then we do e. We stick e in there, and the natural log of e is 1. Then times minus 2 is minus 2. Minus 2 plus 1 is minus 1. But when the fun is done, our function is negative. So what does that mean? That means that we're decreasing from root e to infinity. First time I saw this, I dropped things too, Howard. Looks like you're ducking. All right. So then, we're decreasing. We have to show one more thing. The limit as k goes to infinity of the link divided by k squared, we see that's infinity over infinity. So that's an indeterminate form, so let's go to the hop, yo baby. Derivative of the numerator is 1 over k divided by derivative of the denominator is 2k. Then I say, I divide by k, elongate my 1, and I have 2k squared in the denominator. But where does that go? That goes to a big skinny 0. So by 1, 2, 3, we see the alternating series test gives us our original series does what? Satisfies all 3. So it converges, and then it's all over. Maybe.